Hi, I'm Joe Chamberlain, a Senior Research Engineer in the Metal AM team, and today I'm going to talk about a recently completed project in beam shaping with the University of Bristol. The aim of this project was to develop high productivity beam shaping parameters on the AMCM M290 with Constellium's CP1 aluminium alloy. And essentially it would allow us to build a thrust chamber significantly quicker than what we could do on a standard platform such as an M290. So the project involved taking a functional component. In this instance, it was a thrust chamber from the University of Bristol's CEDS rocketry team. And we baselined this, so we built this on an M290 with standard CP1 parameters. And the first build took approximately 43.5 hours to complete on a single laser. We then started working on the high productivity beam mode parameters on the AMCM, and that essentially involved lots of design of experiment builds to identify a working parameter set. Once we had a working parameter set and we had an idea of the indicative mechanical properties, we could then take that parameter set and run the same thrust chamber on the AMCM, and that allowed us to build the same thrust chamber in just under 20 hours with a dual laser setup. For a like-for-like comparison, if we were to use a single laser, as we did on the M290, we would save approximately 13 hours. So the key outcomes of this project is that we've used beam shaping to build our thrust chamber 55% quicker with a dual laser setup, or 30% quicker with a single laser setup. We also have equivalence in mechanical properties, but ultimately this is a meaningful step forward for both industrial and research applications with beam shaping.